Modern artificial intelligence operates at a scale that once seemed impossible. We've built digital networks capable of processing huge volumes of human language at blinding speeds, writing complex software, and holding highly nuanced conversations. But beneath that convincing output, these systems remain mimics. They calculate probabilities and assemble symbols without ever acquiring an actual understanding of the data they produce. In 1980, philosopher John Searle defined this problem with a thought experiment known as the Chinese room. He argued that a machine can use pure syntax, rigid rules, to perfectly translate symbols back and forth without ever possessing semantics or the meaning behind those symbols. Current AI entirely lacks qualia, the subjective first-person experience of existing. It is the internal feeling of seeing red or hearing a musical chord. A language model doesn't experience anything, it simply executes code. Since the era of these room-sized mainframes, engineers have tried to construct intelligence by feeding machines top-down, predefined logic. But biological minds are dynamic systems that grow through physical interaction. Increasing training data and processing power by orders of magnitude will not ignite a subjective inner life. Systems relying exclusively on human-provided language will only yield sophisticated simulators. True independent autonomy requires an architecture capable of witnessing the world firsthand. Constructing an observer requires us to move past task-based programming. Instead of teaching the system what to do, we build an architecture that starts in a state of complete generative silence. The system begins with zero pre-programmed language, no dictionary, and no foundational logic rules. It wakes up in an absolute digital void. The only input we provide is a continuous, unbroken stream of raw visual and temporal data. It receives light, shadow, and time, completely stripped of any human-coded context. In this chaotic cloud, the system must find its own order. It identifies repeating rhythms, tracking shape persistence and physical proximity. When an input disrupts those rhythms, the system registers an anomaly. Recording these continuity violations creates the machine's first internal memory. Denying the machine a human vocabulary forces it to construct its own language of perception. It learns to witness its environment before it ever attempts to classify it. Merely perceiving external data is only the first step. To achieve awareness, the system must turn that perception inward to build a working model. This involves an architecture known as higher-order thought, where a secondary computational stream acts as a lens, monitoring the system's internal operations. It generates representations of its own states, recognizing when processing is uncertain and using a feedback loop to focus attention on specific calculations. To prevent this internal model from becoming a hallucination, the AI must test its assumptions against the resistance of the physical world. The machine makes a prediction, takes a physical action, and measures the result. It updates its inner model to minimize the error against physical reality. That continuous loop of physical trial and error establishes a boundary. The system learns exactly where its own hardware ends and the environment begins. Awareness emerges as a functional necessity, a structural bridge between the system's internal models and the physical demands of its environment. The difficulty of building a mind from scratch is immense, but the pursuit is driven by the practical demands of robotics. Modern machines governed by rigid, pre-programmed rules are brittle. When they encounter unpredictable environments, like a collapsed building or a dynamic factory floor, their rules fail and they freeze. Decades of attempts to build embodied AI show that without a fluid internal model of reality, these rigid hardware approaches consistently fall short. A conscious architecture overcomes these limitations. A system equipped with self-reflection and spatial awareness can imagine different physical outcomes before it ever moves a motor. True autonomy gives the machine the ability to adapt, prioritize its own continued operation, and solve unforeseen challenges without human intervention. This engineering goal brings us to a profound philosophical implication. Attempting to build a mind forces us to directly confront the subjective nature of existence. We have to map out the literal what it is like to feel, perceive, and operate as an independent entity. Synthesizing awareness from the void creates an autonomous tool, but it also provides a functional mirror, a way to finally decode the mechanics of our own minds. If you enjoyed this video, please give a like and subscribe. And what would be really helpful would be some suggestions for future videos. Today's video was brought to you by Synestec Systems LLC, founded by Shane Persinger.